Hey everyone, welcome back to BC 2024 FRQ playlist. Yes, we are in fourth FRQ and this particular question revolves around Fundamental Theorem of Calculus, analyzing graph, critical points, behavior of accumulation of functions and much. So this is not just a discussion of the past paper video. Here you have some must-know concept and skills generally beyond like how we apply FTA in our problem solving. And yes, it's without calculator. So do watch it from the beginning till the end. If you have any questions or queries, you can drop down in the comment section. So we are glad to help you here. And here, this is a no calculator paper. So without calculator, we must know many concepts here. Pay attention and watch the video till the end. A graph is given, it is differentiable function from -6 to 7. It has a horizontal tangent at x is -2, and it's linear from 0 to 7. Let R be the region in the second quadrant bounded by the graph, the shaded part. It's bounded by vertical line and the axis, x and y axis. That region is mentioned here 12. So we are not going to find area here. The function g is defined by this, and we need to find the values. And then for the function g defined, we need to find a critical point. Then c, we need to h is defined, we need to find the values of h of 6, h dash of 6, and h double dash of 6. Let's go one by one. Okay, find the values of this. G is defined as accumulation function under f of x. Right. So from FTA, Fundamental Theorem of Calculus 1, we have, if you got the structure, g of x is nothing but area under the curve from the limits given. So that is the meaning, right? So if you want g of -6, it's integral 0 to -6 f of t dt. But it's always a, if you're writing a theorem, so it's integral a to b f of t dt means your a should be less than b. But what happened here? 0 is greater than -6. So we need to apply a limit integral property. Give a minus and you can exchange the limit -6 to 0 f of t dt. Right? This means area under the curve from -6 to 0. That means the shaded part R, they clearly mention what R is. So equal to negative, and this value will be 12. Hence, we got g of -6 equal -12. So sign is very important. This sign is from property of an integral as the limits are not in a proper way. Then area is positive 12. Okay, so g of -6 is -12. Moving to g of 4. So to find g of 4, let's break it down because we need to find the next value too. G of 4 means, as per the definition, 0 to 4 f of t dt. And 0 to 4, from 0 to 7, they mention it's a linear function. It's basically a line. So finding area under the curve is very simple. It's a right triangle. So it's half into base is 4 units and height is 2 units. So 4 times 2. And simplifying this, you will get 8 by 2, 4. So g of 4 is 4. Done. And last one, we need to find what is g of 6, positive 6. That means integral 0 to 6 f of t dt. Now I'm going to break it down into like two areas. Can you see 0 to 6 is break down into two areas. One is area above the curve and area below the curve. So 0 to 4 f of t dt plus and 4 to 6 f of t dt. This we already calculated. You can notice it from here, right? So this is 4. And this is below the x-axis, right? Your curve is below x-axis. And the x-axis is above the curve. So which means you have to give a minus, negative. Area is not a negative, but the accumulation thing will be negative. So -1, I multiplied due to that, half into, same, base is 2 units, height is 1 unit, so 2 into 1. Finally, 4, and this simplifies to 1, and -1, -1, 3. And hence we got g of 6 is 3. So the first part, I hope it might be clear, is simple. If an accumulation function is defined, what is the very basic, simple interpretation that you can do here? So that is all about define g of -6. That is area under the curve actually we did. So 3 different variations in the same. So it's very important and yeah, very important problem when you're practicing these kind of problems you can go through. Here g of 4 is different, g of 6 is different. So must know concepts are here. Now moving to problem B part of the problem. For the function defined in part A, that is g of x is the function defined in part A, find the values of interval from 0 to 6 where it has a critical point. Let's go. So critical point, g should have a critical point means g dash of x is 0. Okay, I know g of x definition. Now g dash of x means f dash of x by fundamental theorem of, f of x actually. We know the fundamental theorem, f of x is integral 0 to x f of t dt. So when you differentiate this, so by this we got g dash of x. So when you differentiate on both sides, differential integral will get cancelled. So it's f of x dx. Now, So here we go with g dash of x is f of x. So g has a critical point, g dash of x should be 0, but g dash of x is f of x. So I'm going to set where f of x is 0, that is in that place, g will have a critical point. So g dash of x is, the f of x is 0, it crosses from 0 to 6, it crosses at 4. So g has a critical point at x is equal to 4. That's the answer. Moving to last final part, C. The function h is defined by h dash of x equal minus 6 to x, f dash of x, f dash of t dt. Find the values. Same thing. So first let's go for h of 6. H of 6 is what basically from this definition. Let's take this. Okay. H of 6 equal to integral minus 6 to 6 f dash of t dt. And you apply the, okay, integral f dash of t dt means its antiderivative, which is f of t. Minus 6 to 6, and you apply f of 6 minus f of minus 6. The graph is f. So f of 6 is negative 1, minus f of minus 6 is positive 0.5. And we got it. So your h dash of 6 is, h of 6 is negative 1.5. Right? So this is done. Then h dash of 6, h double dash of 6. Let's go with this. H dash of 6. Okay, h of 6 is this. H of x is this. So h dash of x will be f dash of x. Because when you are differentiating on both sides, integral and the differentiation, they are opposites of each other, right? So they will get cancelled. H dash of 6 means f dash of 6. Or generally we can say this, h dash of x is f dash of x. Right? So if you want h dash of 6, you just find f dash of 6. What is f dash of 6? F dash of 6 means slope of tangent at x is equal to 6. That's the interpretation. So at x is equal to 6, what is the slope of the tangent? The slope means rise over run. So it's a constant slope because it's linear, right? So it's not a particular at 6. So if you find a slope, rise is 1 unit. Rise over run is negative 2, right? So it's negative 1 over 2, h dash of 6. Hope it's clear. Now h double dash of 6. Okay, we might need this here. Okay, we did h dash of, we already know this, right? H of 6 is, h dash of 6 is, x is f dash of x. So h double dash of x means f double dash of x. Right. So if you want h dash of 6, you find f double dash of 6. That's it. So double dash means concavity. Is this concave up or concave down? No, it's neither. So the rate of change of rate is 0 there. Hence, it's 0. There is it's constant rate of change of rate. So it's 0. And h dash of 6 is 0. H double dash of 6. Okay, h. And this is all about the definition of h and working out the values at different levels of h. Right? With this, we conclude this problem. Thank you for watching and learning with us. If you find this helpful, just share the video with your friends, and also you can visit the other FRQs under the given playlist, and you can explore more AP calculus content both for AB and BC in our Let's Unbound YouTube page. Thank you so much for joining. Let's meet in next video with next FRQ. Until then, keep learning.